Okay, we saw in our last video that solving something with two variables in it isn't a simple task. We can't just get x by itself. If there's just one variable, you can just go for it, get the x by itself. But if there's more than one variable for these types of equations, we need other methods and other tools, because we need to be able to solve these. One way to solve an equation with these two variables is by graphing. Now, what we're talking about specifically is a quadratic. So this chapter, this says chapter 5, but it's really chapter 4. This chapter is on quadratics, which is any equation where the biggest power on a variable is a 2. It's a square. So here is the parent function. The parent function of a quadratic is y equals x squared, where nothing special has happened to it. You plug in -3, you get out 9. You plug in 2, you get out 4. And the graph makes this V form. Every parabola, I said it's a V, it's really a U. It's a U because it has this curve the whole way. There's no corner. There's no point it comes to. So when you're graphing them, make sure to make that bottom part curved here at the vertex. Every parabola looks like this. It can face up or face down. It can be really narrow, really wide. I should pick a color that's easier to see. But they all look something like this. If you ever graph a parabola, a quadratic, that isn't symmetric and curved, you've done something wrong. Go and find your mistake. So when graphing these quadratics, one way to go about this is just by making a table and plugging numbers in. The standard form of a quadratic is y equals ax squared plus bx plus c, where a, b, and c stand for numbers, but x and y are just the variables x and y. So like here, a in this equation is 1, b is 4, c is 3. And if these numbers were negatives, I would say they were negative, but they weren't. And one thing we can do is just plug in points and graph it. But you're going to find that this isn't the most efficient or effective way to do this. Like if we plug in -3. -3 squared is 9. 4 times -3 is -12. So 9 minus 12 plus 3 is 0. So we plug in -2. -2 squared is 4 minus 8 plus 3. Well, that's -4 plus 3 is -1. We plug in -1, we get 1 minus 4 is -3 plus 3 is 0. We plug in 0 and we get 3. We plug in 1 and we get 1 plus 4 is 5 plus 3 is 8. We plug in 2 and we get 4 plus 8 is 12 plus 3 is 15. The next one's going to be 24. If I try and graph this, -3, 0, -2, -1, -1, 0, 0, 3, 1, 8, and that's really all I'm going to be able to fit on here. The rest gets so big. It's tough to look at this and see what this parabola is doing. Now, luckily, we actually hit the lowest point. We hit the vertex, so half of the parabola is here. And at this point, we can make some inferences. We know that parabolas are symmetric, so the other half is going to go kind of like this. But I'm not happy with just drawing out a curve like that, and you shouldn't be either. We want to have specific points we can work with. Just grabbing the numbers from -3 to 3 wasn't precise enough and wasn't the correct domain to work with. Just plugging in points is doable, but it's not ideal. Let me go through another example of this. X squared minus 8x plus 7. Well, I'm going to plug in these numbers and I'll do this a little bit faster. -3 squared is 9, plus 24 is 33, plus 7 is 40. -2 squared is 4, plus 16 is 20, plus 7 is 27. 1 plus 8 is 9, plus 7 is 16, 0, 0, 7. 1 minus 8 is -7, plus 7 is 0. 4 minus 16 is -12, plus 7 is -5. 3, I get 9, minus 24 is -15, plus 7 is -8. And if I were to try and graph these, I don't even, they're all going down. You know, this went down by 13, down by 11, down by 10. I'm not really sure what this change is here. But this isn't a good way to graph. By making a table, I'm just going to have half of the parabola, and I'm not even sure where it goes. So I have to keep on plugging in 4, 5, 6, or maybe plug in -4, -5, -6. I'm not sure. Let's learn how to do this better. And before we do that, how do you graph x equals -2? Remember that? This should be something that just pops in your head, and you're like, oh yeah, it looks just like this. And by just like this, I mean a vertical line going through -2. Wow, that was thin. That is the line x equals -2, because at every point along that line, the x value is -2. We're going to use vertical lines in this. In standard form, there's a few things that we can look for in these parabolas. A y-intercept, an axis of symmetry, a vertex, roots, domain range, all these things. So every parabola has a few features to it. They all have a y-intercept. And that y-intercept always happens at wherever this c value is. It's always at the point 0, c. Every parabola has what's called an axis of symmetry. That's this line right here. The axis of symmetry is a vertical line that cuts the graph in half. That's why I had us refresh what an x equals line looks like. This is the equation of the line that cuts the graph in half. Every parabola has one. Every parabola has a vertex, and the nice thing about the vertex is the x value of the vertex always matches whatever the AOS was. The line of symmetry, the axis of symmetry, will always pass through the vertex. So you find the axis of symmetry by doing x equals negative b over 2a. You calculate negative b over 2a, and that's where the line of symmetry is. Then you take that and you plug it in to your function. Let's see if this works. You plug it into your function, and it'll tell you where the y value is. There it is. You do f of negative b over 2a. That's what that's trying to say, f of negative b over 2a. You take your AOS, plug it into your function, whatever it spits out is the y value of your vertex. There's other things we can find also. We know if the a value is positive, the graph will go up. I say it smiles. This graph here is smiling because the a value is positive. But if the a value is negative, the graph will go down. It frowns. If you have a negative a value, the graph goes down. There are also two things called roots. These are called roots, or they're called x-intercepts, or they're called zeros. All three of those terms mean the same thing. We don't know what those are by some quick little trick from ax squared plus bx plus c, although we will find lots of ways to find those as we move forward. So let's graph this. I have y equals x squared minus 6x plus 5. So right now the a value is 1. The b value is negative 6. The c value is 5. 1, negative 6, 5. I know there's a y-intercept at 0, c, which in this case is 0, 5. So there's a y-intercept right there. I also know since the a value is positive, the graph is going to point up. It smiles, so it'll be going kind of like this. I'm going to find the axis of symmetry, which is negative b over 2a. Well, right now the b value is negative 6. So to do negative b over 2a, that's negative negative 6, which is positive 6. 2 times a is just 2, because in this case a is 1. My AOS is at x equals 3. So I'm going to draw that vertical line at x equals 3. I like to make it dotted. I'll make it thicker than that last one. This line right here cuts my graph in half. Half will be on the left side, half will be on the right, which actually means this point here, I can count 1, 2, 3, 1, 2, 3. There's another point over there. There's a symmetric point on their side. So whenever you find a point on one side of your parabola, you've really found the point on the other. Now I'm going to find the vertex. I'm going to take that number and plug it into my function. I'm going to do f of 3. Well, f of 3 spits out 9 minus 18 is negative 9, plus 5 is negative 4. It's the point 3, negative 4. This right here is my vertex. It's the lowest point. Now that I've found the vertex, here's where you can start making a table. This is one of the handier little things to do. I'm going to put the vertex in the middle of my table, 3, negative 4. And if I put the exact vertex in the middle of my table and then count up and down by the same amount, I should have this symmetric little form to it. So now I'll just plug in some more points, like 2 and 1 and 0, and this will give me a good graph. So I plug in a 2, I get 4 minus 12 is negative 8. Plus 5 is negative 3. It's symmetric, so whatever I get on the left side, I get on the right. If I plug in a 4, I'll also get out negative 3. And I plug in a 1, 1 minus 6 is negative 5, plus 5 is 0. It's symmetric, so whatever I get on one side, I get on the other. Here is my parabola. Try and make it smooth and curvy, and don't let it come down to too much of a point down here. Keep it kind of U-y and curvy down there. Beautiful parabola. The domain of every parabola that we do will be all real numbers. X is going from negative infinity to infinity. The range will never be all real numbers because there's a highest or lowest point. There's a maximum or minimum. In this case, the minimum value is negative 4. That's the lowest point the graph reaches. This is going from negative 4 to infinity. And if you ever asked for the minimum or the maximum value, look for the vertex. It's the y value of the vertex. Let's do it again. This might be one for you to pause and try on your own. The A value is -2, the B value is 6, the C value is -4. So first of all, the y-intercept is at -4. The AOS is at -b over 2a, which is -6 over 2 times -2, which is -6 over -4, which is 1/2, or sorry, 1.5, 1.5. So my line of symmetry is going to be between 1 and 2. That's fine, I can live with that. To find the vertex, I'll do f of 1.5. I'm going to want a calculator for this one. -2 times 1.5 squared plus 6 times 1.5, which is 9, minus 4 is 0.5. My vertex is at the point 1.5 comma 0.5, so it's here in the middle of this box. So now I'm going to make a table, and in this table I'm going to put the vertex in the middle, 1.5 comma 0.5, and then I said to go up and down by the same amount, but what that really means is always be the same distance from the vertex. So here I went like half a unit, and then 1.5 units, 1.5 units, and that's fine. If your vertex, if your AOS isn't a number like a whole number or a half of a number, it's not going to be quite as pretty, and we'll just cross that bridge when we get there. We know if we plug in a 0, we get out -4, which means if we plug in a 3, we'll also get out -4. That can be worth checking to make sure you're doing this right. So 9, -18 plus 18 is 0, minus 4 is -4, perfect. Let's plug in a 1, and you get 1, -2 plus 6 is 4, minus 4 is 0. So here's -1, 0. Sorry, this was not a negative, that was just 1. So it's the point 1, 0, and 2, 0. Now what we found there are the roots. This has a root at 2, 0, and a root at 1, 0. Sometimes those roots won't be whole numbers, and then for now, when that happens, estimate. Say it's like between 1 and 2, or it's 1.2 or something. Just estimate what it is. The minimum, this has a maximum value because it's pointing down. The maximum value is 0.5. That's the highest point this graph reaches, 0.5. Domain, all real numbers. Range from -infinity to 0.5. Good. Let's talk about how to do something like this. Now this is going to have a huge AOS and vertex. The AOS of this is going to be -b over 2a, which is 15. So the middle of this graph is going to be at 15. The vertex of this graph is going to be at, what was it, -15 squared, come on, -15 squared minus 30 times 15 minus 12. That's at -687. And the y-intercept is at -12. So this graph would be a pain to A, do by hand, but B, probably wouldn't be all that useful to do by hand. This is where it's better to use a machine. So I'm going to try and graph this on my graphing calculator. I'm going to type in, I go press up here y equals, and I do -x, there's my x button next to alpha, -x squared plus 30x minus 12. And when I go to graph this, I press the top right button up here. When I go to graph this, it gives me a bit of a parabola here, but it's nothing that I can really work with. I'm assuming it's going, it's going to go all the way up here to 687 and come back down somewhere over here. I'm not sure where that is. And so right now, this is where a graphing calculator doesn't feel that useful. And the fact of the matter is it's not terribly useful if you don't understand what you're doing. We found the AOS and the vertex first. What was the vertex? I forgot. It was -687. Oh, so it's actually going the other direction. The graph is actually going like this. That can't be right. Hold on, something's up here. -15 squared plus 30 times 15 minus 12. Let's change this. This should be a 30. 213. Okay. Let's just start this all over. Okay, now let's graph this one. We're going to find that graphing this one is going to be much more difficult to do by hand. I mean, the y-intercept is negative 12. But the AOS is going to be negative b over 2a, which is negative 30 over 2 times negative 1, because the a value is negative 1, which is 15. The AOS is the line x equals 15. So then I'll try and find the vertex. I'll do f of 15, and I don't want to do that one in my head, so I'll grab my calculator. I get negative 15 squared plus 30 times 15 minus 12, and that's 213. And I also know this graph is pointing down because it has a negative a value. Well, I don't want to try and graph the point 15, 213 while hitting a y-intercept of negative 12. Graphing this precisely by hand would be a chore and also probably not necessary or worth it, so instead let's graph it on our calculator. I'm going to go to my y equals menu right up here in the top left and type in negative, not minus. Negative and minus are different. There's minus, there's negative. They're very, very different. Negative x squared plus 30x minus 12. And when I graph this, it's not going to show me much that's useful, right? Because it's just showing me this part here, but it's going to be doing all of this stuff. So I need to manipulate the window of the graph to give me a picture of something that I want to actually look at. This is where having a graphing calculator isn't all that useful if you don't know how to use it, but also if you don't understand the math you're dealing with. Because I found the AOS and the vertex, I now have a very good idea that this graph is going to go as high as 213. I know for a fact it's going as high as 213, but in terms of its domain, it's probably not going much past 30. I'm going to have it go to 40 just to be safe, but now I'm going to change the window of the graph to match the things I know about the equation. So I go to the window button right there. The minimum x value to show is negative 10. The maximum x value, let's try 40 and see what happens there. This is just a domain, so the picture on the graph is going to go from x values of negative 10 to 40, and the scale means what to count by. Let's count by 5s. The y's are going to go from, let's say, negative 100 to 220, so let's do 250, and let's count by 25s. So the x's are going from negative 10 to 40, the y's are going from negative 100 to 250, and I had the y's count by 25s because that spread is kind of big. I picked those numbers because that was the vertex, the highest point the graph reaches, and this is going to be kind of the middle of the graph. Not always the middle. In this case, it's a little bit off from the middle. This changes how far off from the middle it is. But so it's going to be kind of close to, well, okay. Middle is not the right term to use. Anyways, let's just graph this, see what happens. Ah, there's a picture I can work with. Now I can see how that graph is going. I can count 25, or 5, 10, 15, 20, 25, 30. So this intercept here is right around 30. And 25, 50, 75, 100. A little bit above 200 there. If I wanted to actually find specific things, I can press second graph. Nope, I'm sorry, second trace. Second trace gives me all these options. Like if I want to find the maximum, that's the fourth option. That's to find the vertex. It gives me this little spider thing. I scroll to the left, so I'm on the left side of the vertex. See that says left bound? And I press enter. Then I scroll to the right, where I'm on the right side of the vertex. It says right bound. I press enter. It says guess. Ignore that. Press enter again. There's the vertex. 15, 213. Sometimes these little decimals pop up because the machine has to do some calculations. Ignore it. That's the point, 15, 213. I can find the vertex that way. I can also find where two lines cross each other, or I can find the intercept. So I can find the value. To find the value is kind of silly. If I press this first one, it just wants you to plug in x. So now, like if x is 3, y is 69. I can keep doing that. If, say, x is 5, well then y is 113. But I can also do that at the table. Second graph pulls up my table. If x is 0, y is 12. If x is 1, y is 17. If x is 3, there's our 69. If x is 5, there's our 113. Right now it's just counting by ones. So if you want to generate points from a table, this is the place to do that. You can also press second window, and that does table setup. Change the things in your table. What I like to do is change the independent variable, x, independent, to ask. So now when I go back to the table, I can type in whatever I want. So I would set that up if I were you. Second window to change your table setup. These are all things you will forget to come back to these videos and watch them. We can also do all of this on Desmos. Desmos is wonderful. That was me reading about soccer. Ignore that. Here I can just type this and go to y equals negative x squared. And if you can't find x squared, this is kind of cool. You can just do xx, because x squared means, oops, x times x. So if I do negative x, go deck down. This probably wasn't worth it. Y equals negative. On Desmos, negative and minus the same thing, so don't worry about that. I could do that for x squared if I wanted to. Negative x squared, I'm forgetting what the numbers were, plus 30x minus 12. Now, this has the same problem that our graphing calculator had. But you can use your two fingers, you can use your zoom in, zoom out. If you're on your iPad, you can just zoom in and zoom out. But if you can't do, oh, and there's this here. And that can be nice. The problem with zooming out is sometimes the x's get way too narrow. And you want to just change the x's and not change the y's. That's easier on your iPad than it is here, but you can just press settings. Let's have the x's go from like negative 20, I think we said about 40 was good. Negative 20 to 40. And the y's should go from, like, I don't really need negative 139. Let's just do like negative 50. Good, nice little graph. There are the basics of graphing parabolas. We'll talk a lot more about them. And remember, our goal here was to be able to solve. We didn't even talk about solving yet, just graphing. But once we learn how to graph really well, then we can start solving, so we can look forward to that and be super excited. See you next time. Wow, that was a long video. What's the deal with this guy just talking and talking and talking? This is the part of the video at the end where I tell you to do things, where you need to like listen to me and share my video if you found it helpful. Like if you got a friend in class and you say, hey, I know this guy who makes videos, check him out. Then yeah, send out a link or subscribe so you can see more of my videos later and maybe see more of these cool animations. This is a point going around an ellipse at different speeds acting like an orbit. And that thing bouncing in the middle just makes pretty designs, although right now it's pretty lopsided. I can also just tell you to do other things like eat food and drink water and stop Snapchatting people so much, but you're not going to listen to me if I say things like that. Thanks for watching. See you next time.